Welcome back to the program. Today we are going to discuss about the cause and effect forecasting. As you know, there are three models for forecasting. One is qualitative model, second is time series forecasting, third one is cause and effect or regression modeling. Of course, qualitative model depends upon one's own judgment and using expert modeling that can be. So, coming to time series, we are going to observe the pattern in the time series and then extrapolate for the future. When it comes to cause and effect, it is somewhat different where we are going to determine what is dependent variable and what are the independent variables and try to determine the relationship between dependent and independent variables. Let us understand with respect to simple example by using a Excel template. Let me share the screen. Here, if you see, specifically, we are talking about the uh, cause and effect model or regression model here. So you have a data year for maybe and quarterly data for 3 years. Okay, quarterly data for the sales, and you have other dependent factors here. Maybe you see in terms of the pricing and the spending, GDP, PCE. These are the other factors which can affect the sales. Okay, let me put the table in clear. This is the table for the first 3 years. Quarter wise, you have the data on sales, and of course, you have other factors which impacts the sales. Here, for example, average price can impact the sale. Second one be it could be advertisement expense. The more advertisement you are doing, it's going to impact the sales. The other one is naturally GDP. In a positive GDP growth, then sales is also expected to improve. And PCE is something like a consumer price index in India. It could also be something similar to inflation. In US, they use something called personal consumption expenditure. Okay, so assuming that these four are going to impact the performance of the organization in terms of a demand. So in time and cause and effect, we are trying to find the relationship with each of this with respect to the sales. Okay, wherever the relationship is high, then we are going to use such a parameter. Of course, there is something called coefficient of correlation. If you plot that, then you will be able to see. For example, hope many of you might have this data analysis pack already installed in your system. If you see, one of this analysis is the correlation analysis. So here you can give the input range and labels in the top row, and I can generate the output in the same sheet somewhere here. And when I generate output, you are going to get the relationship among these different factors. Of course, here sales is an independent factor, and all other parameters are dependent factor based on which it can impact on the sales. As you see, the price is having negative impact of 55%. Media spending is roughly 79%. GDP is 89, which is the highest impact, and PCE, personal consumption expenditure, is 88%. As you see in this comparison, the GDP and PCE has highest impact. Of course, when you get to one, and then the relationship is perfect. When you get zero, then it is no relationship at all. When you get a minus, then you can expect a totally opposite relation. So when we do cause and effect analysis forecasting, we use this coefficient of correlation, and then in a single regression we use the independent parameter which is having highest correlation. In this case, GDP is the highest correlation, Of course, you can also plot the graph and see how the movement in time series. Normally, we would have observed the pattern in terms of trend and seasonality, but cause and effect we do not use it. Okay, when it comes to single linear regression, of course, we are going to use only one. In the multiple linear regression, we may use multiple independent variables, but in simple linear regression, for example, where the correlation was more, we are going to use that in building a model. Okay, what we are trying to do is to do the forecast for the year 4 quarter 1 by building a simple model. Hope all of you may be aware that when I say model for simple linear regression is y is equal to a plus bx. Okay, so in the you are trying to build a line and trying to find out the intercept and the slope for the given equation, and you are trying to build this equation by doing so. Okay, by building a simple linear regression by doing so. So here also you need to have the data analysis pack. If it is available, you can just go to data analysis, and there you can see regression is one of the item available. And when you choose this input white range, range is nothing but the sales, and the x range, of course, here we are selecting only one. In this case, GDP I am using. If you are using multiple regression, you can select the other one, two, or three, whatever is required, you can select. Of course, I have selected the label in the top row, and then providing output location. Of course, you have other possibilities here, for example, finding out residual and other things. So I have to cover the label. Here I have used C5 to C17, and label here also I should use C5, and then build the regression output. Okay, so you get the statistics easily in Excel also, but of course you can use either SPSS or Python or any other software packages to get build this regression model. Okay, so you can see the coefficients are clearly available here. Okay, intercept is minus 3888, and slope is given by 0.87. So you can as well build the model. For example, y is equal to a plus bx is the equation model. Let me zoom it for your clear understanding. Okay, now if I want to build this model, I have a available here plus the coefficient for the slope is available here, and I have the value of GDP provided for the year 4 quarter 1. So I am including that to arrive at the forecast for the year 4 quarter 1. If I do that, I get this value. Okay, 4066. So this is a very simple way of building a model, and most of the time this is better than the time series model. And you have many ready-made algorithms available in Python and machine learning. But as you see, you can also build this model in Excel. Okay. Also, for validating the model, you have various parameters. For example, R squared, adjusted R squared. For example, this says the model is fitting up to 77%. Of course, the expected is 100%, but any of the statistical model cannot provide as such accuracy. The reason could be we are not including all the parameters. Possibly, if you are including in multiple regression more than one independent variable, the results are expected to increase. So you have roughly 20 to 23%, which is not explained by this model. In any case, You can build the forecast by using the model, observe over a period of time, and then check whether this is valid or not valid. Of course, most of the time, 80% of the time, this model is valid as per my experience. And you can also see the T statistics, which is expected to be plus 2 and above for the model to be better. Of course, the p values are also given. It should be lower than 0.05. And you see, the values are somewhat okay. So when you get the actual result, you need to compare the actual with the forecast. Let us see what is the amount of error we are getting. So it says 50 million is the error. If I convert that into percentage, I can get around minus 1.25%. In fact, practically many of the industries are struggling with the error rate of 10 to 20%. But if you are able to get less than or in even in a single digit, that seems to be fine. So this is a demo of cause and effect like that. In some of the other session, we have done a time series, and our program is basically based on such. Working for various models in supply chain. Of course, apart from forecasting, we are going to do on inventory modeling and logistic routing and various optimization model. Just to give a brief introduction, this session was done that you can start Excel as a foundation, start doing forecast by using the statistical tool which is already present in the Excel. If you have any queries or any clarification on our program, you are always welcome to reach to me or our team. Thanks for watching. Bye.